Welcome to Principles Engineering. Today we're working on some stress strain calculations. We're going to use the methodology that Project Lead the Way teaches us how to use. So our first problem, if you look at it, is up on your screen right now, and you'll see they talk about an 18,000 pound weight is supported on a rectangular base plate that's 9 inches by 2 feet long, and the plate rests directly on a concrete slab. So we want to determine the stress that the base plate exerts on the concrete slab. We're going to look for pounds per inch squared and pounds per feet squared. Alright, that seems straightforward enough. So let's take a look at the layout that they ask us to use. They ask us to use a layout where we are given some boxes where we can write our knowns, our unknowns, equations, and then we can look at our solution, our substitution, and our final solution. And we'll do a little sketch in the middle here in blue. So let's start out with what we know. We're going to write down what we know in yellow here. And what they've given us is they've told us that the width of the plate, so I'm just going to call that W, is 9 inches. They've also told us that the length is equal to 2 feet. Now we're going to want to express these in similar units here in just a moment. And they've told us that the force is equal to 18,000 pounds. And we'll call them that pounds force. Our unknowns in this is we don't know what the area is of the plate, and we also don't know what the stress is. So let's talk about some equations that we know we're going to be able to use here to solve this. And the first equation we're going to be able to use is the area. And the area of a rectangle equals to length times the width. And while we're on that topic, let's go ahead and draw the diagram that they've shown us. And what we have is we've got a rectangle here in the middle, in blue. And I've got a force going down into it. So I'm going to draw that as a dot pushing down from the top view. And this is 18,000 pounds. And this is 9 inches. And let's just keep it in the same units. This is 24 inches, or 2 feet. So let's start out and look at what our formula is for stress. And the place to look for this formula for stress is in the handout. And we've got a material formula sheet, and you'll see that pop up on your screen right here. And we're really looking for stress as the normal stress right here. And this is going to be the force divided by the area. And it should be represented in pounds per inch squared. Our question asks us for another way to put it. But let's start out in pounds per inch squared. So the first thing I need to figure out is I need to calculate for area. So I'm going to do my calculations over here in this pink color. So the area equals to the length times the width. And in inches squared, it's going to equal to 9 inches times 24 inches. So we've got our two length and width there. That ends up being (216 square inches). Now we know that our sigma here is also going to equal to the force divided by the area. And that is one of our equations that we pulled off of our sheet. So stress equals the force divided by the area. And I'm going to put the units here, PSI, or pounds per inch squared. So our force right now, which was given, is 18,000 pounds, not 1,800 pounds, sorry, 18,000 pounds. There it is. So our equation here, we're going to substitute in 18,000 pounds force divided by the 216 inches squared. That is going to give us a solution of about 83 pounds force per inch squared, or PSI, pounds per inch squared. So that gives us our stress is 83 pounds force per inch squared. Now, one part of this question here, it asked us to convert it into pounds per foot squared. So that is a little bit of a different equation. So there's two ways I can go about this, and I'm going to go ahead and do this one over here in white. Actually, let me do it in off red. One way I can say that is 1 foot equals to 12 inches. Therefore, if I square both sides of the equation, 1 foot squared equals to 12 inches squared, or equals to 144 inches squared. From that, I can derive a new equation here, and that equation is going to be a conversion factor, and that's going to be to go from inches squared. So I'll write it like this: inches squared, 144, 1 foot squared. Or, conversely, depending on where I want to get rid of the unit, same thing. So let's go ahead and apply that solution here, and let's convert this to 83 pounds force per inch squared, and then use my conversion factor right here of 144 inches squared per foot squared, and multiply that out. And I think they ask for it for the nearest 1,000, but we'll give the full answer here, and then I'll let you play with it if you'd like to. 144 times 83 ends up being 11,000. Let me undo that here real quick. Sorry about that. 11,952 pound force per foot squared. And you may sometimes be called upon to put it into pounds force per square foot, but more commonly is a PSI. So that's the first problem. So we went through the process here of determining what our knowns were, figuring out what we didn't know, giving equations for each one, a conversion factor, a little sketch that showed the forces, and then substitute and solved. Thanks for watching.